Hi guys, today we are going to look at something very common in computer architecture. That is the diagram displayed on the screen, a multiplexer. A multiplexer is a device that selects one input out of several and forwards it to a single output line. Let's think of it in the real life. Think of it like a traffic light controller. It decides which data gets through based on a control signal. About the diagram, the description of the diagram. Here is a 4-to-1 multiplexer, which means it has 4 input lines, L0, L1, L2, and L3. It also has 2 selection lines, S0 and S1. These selection lines tells the multiplexer which input to connect to the output. How this multiplexer works. S0 and S1 are control lines depending on their values, either 0 or 1. One of the inputs passed to the output is passed to the output. There are also NOT gates on the S0 and S1, which means we can create all 4 combinations 00, 01, 10, and 11 to select any of the 4 inputs corresponding. Each AND gate checks for a specific combination of S0 and S1 along with the corresponding input. For example, if S1 is equal to 0 and S0 is equal to 0, then L0 is selected. And if S1 is equal to 0 and S0 is equal to 1, then L1 is selected. If S1 is equal to 1 and S0 is equal to 0, then L2 is selected. If S1 is equal to 1 and S0 is equal to 1, then L3 is selected. The output of this diagram. The AND gate ensures only one input is active at a time based on the select lines. Then an OR gate combines the result and gives us the final output. So only one AND gate wins and its input value becomes the output. In real life, imagine you are picking a song from a playlist using a remote. The selection buttons are S0 and S1, and the songs are L0 and L3 to L3 rather. The multiplexer plays the song you choose based on the button combination. The output. A multiplexer helps to routing data in circuits and is used in communication systems as CPUs and more. Example of the output, the table below. In conclusion, how the multiplexer works. This multiplexer chooses which input to pass depending on S0 and S1. Is efficient and used in memory selection, communication, and CPUs.